Hi, welcome to this video. In this video, we are going to solve a matrices question which came in 2018 GCE paper 2. It's a very simple question which you must know for you to enjoy the exam and the preparations. Okay, so it's question 1 and it says, given that the matrix A is this. So the matrix A is given to be what? To be 2x, 2, 3, and x. Okay? And then now, the first question is saying, find the positive value of x for which the determinant of A is 12. So we want to look for the positive value of x of which the determinant of this matrix is what? We have been given that the determinant is what? 12. Okay. So the first step first, enjoy yourself by displaying the formula. So you're going to say determinant of A is equal to major diagonal minus minor diagonal. Like this. So this is your major diagonal. This is your minor diagonal. This is your minor diagonal. This is your major diagonal. Very simple concept of mathematics there. Okay. So we have been given that the determinant of A is what? It's 12. So let's write 12 here. Is equal to, what's the major diagonal? We multiply 2x times x. So we're going to multiply 2x times what? Times x. Minus the minor diagonal, we're going to multiply 3 times what? 2. Okay. So we're going to have 12 is equal to 2x times x is what? It's 2x squared. Like that. Very simple. And then minus 3 times 2 is what? It's 6. Okay. So at this stage, we're going to correct the like terms. Okay. So I'm going to make this negative 6 close the equal sign. So it will be 12 plus 6 is equal to 2x squared. Of which 12 plus 6 is what? It's 18 is equal to 2x what? Squared. From here, we can say that 18, which is equal to 2x squared, it can also be written as what? 2x squared is equal to what? 18. That is, this concept comes as a result of the relationship which is there, the relationship of equal sign. Because A is equal to B, it's the same as B is equal to A. So now for us to remain with x, we divide both sides by 2. So we're going to have x squared is equal to what? 9. So for us to know the value of x, we introduce the square root for both sides. Square root both sides of the equation. Now, why did they say find the positive value of x? It's because when you introduce a square root, we always introduce what? Positive or negative. So meaning that this answer is going to have positive or negative 3. But remember that we are looking for the positive value of x. Therefore, x is equal to 3. This is the value of x. The second question is saying, hence or otherwise, write A inverse. A inverse. Very simple there. So A inverse is going to be, A inverse is equal to 1 over the determinant. 1 over the determinant times, okay, times your matrix. Now with your matrix, what you must know is you must exchange the major diagonal. 2x will come here, and then x will come here, and then the minor diagonal, we multiply them with a negative. That is what we do in terms of rewriting them. Okay. So now, what is the value of a determinant? Is 12. The value of a determinant is 12. Let's check our matrix now. Our matrix, we have 2x. If I can write our matrix by substituting the value of x, by substituting 3 where there is x, it's going to be 6, 3, 2, and 3, like this. If we substitute wherever there is x, we put 3, we are going to have this matrix. Okay. So now try the inverse. I said with the major diagonal, you exchange the elements which are there. You exchange them in terms of the position. So this is going to be 3, this is going to be 6. And then the minor diagonal, you multiply them with a negative. So this is going to be negative 3, this is going to be negative 2. So this is your inverse. As simple as that. Very simple question. But if you want, you can multiply 1 over 12 with whatever element or whatever number in your matrix. So this is going to be 1 over 12 times 3 is 1 over 4. 1 over 12 times negative 2 is negative 1 over 6. 1 over 12 times negative 3 is negative 1 over 4. 1 over 12 times 6 is a half. So if you want, you can leave your answer in this form. You can leave your answer in this form. But for me, I just prefer ending it here so that I can avoid some unnecessary mistakes. So this is a very simple way we calculate the determinant and enjoy the matrix in general.